right, kids, today we are going to talk about section 3.7, graphing linear equations. So some of this will seem like a little bit of a review, and some of it will give you a different perspective on some graphing. So when you are graphing, you need to pick your approach. So sometimes things will look different. Remember, it takes 2 points to make a line. So no matter how you get your 2 points, you need 2 points. So when you look at an equation, think, how can I get 2 points to make my line? Also, start by assessing the problem and determining how you're going to get 2 points. Don't look at the problem and start graphing. Look, think, and then work. All right, if you have any point in the slope, you can find the second point. So whether you are in slope-intercept form or in point-to-slope form, you can graph the function. Some of you just always solve for y, and if that's what you want to do, that works, but it's very time consuming. So I encourage you to look at the different approaches and learn how to use them and learn how to apply them. All right, so there are 3 common approaches to graphing linear equations. The first one is the intercepts. Can we locate the x and the y intercepts? If you can figure out where the graph crosses the x-axis and the y-axis, then you can graph the linear equation. And the other 2 are the slope-intercept and point-slope forms, very conveniently named slope-intercept. If you have the slope and the y-intercept, you can graph the function. And the last one is the point-slope form. So if you have a point and you have a slope, you can graph the function. Okay, remember we've also mentioned the HK format, which is the same thing as point-slope form. All right, so let's tackle the equation 2x minus 3y equals 12. So when I look at this particular problem, I see an equation in standard form. And if I see an equation in standard form, traditionally, I'm going to use the intercept method. And when I think of the intercept method, what I'm going to do is I'm going to cover up part of the equation. So I'm literally going to cover up the 3y. And now I look at the equation, and I have the equation 2x equals 12. And when I solve that, that tells me that x equals 6. So this equation has an x-intercept on your graph at the point 6. Then I do the other. I come over here, I crossed out the wrong one. So I'm going to cross out the 2x this time. So I'm going to come over here. Sorry about that. I'm going to cross out the 2x. Now I'm left with the equation negative 3y equals 12. And if I divide each side by negative 3, I have y equals negative 4. So that tells me that my y-intercept is going to be negative 4. And at this point, I have 2 points, and I can graph my line. So when I look at this, remember that a lot of that you can literally almost do in your head just by covering the 2x with your thumb, covering the 3y with your thumb, and doing the math in your head. So the other thing I can do, if I have 2x minus 3y equals 12, I can solve this equation for y. So some of you tend to do this no matter what. However, to me, this takes a significantly longer or significantly more time. And the other thing it does, if you look at all the work I'm doing, it also opens the door for a significant number of mistakes. So now I have slope-intercept form, and when I look at this, I have my y-intercept right here at negative 4. I have my slope at up 2 over 3, up 2 over 3, which now you can tell I have a y-intercept of negative 4. And if you look here, I have an x-intercept of positive 6, which is what I had before. So as you can tell, there's multiple ways to solve all these equations. You just kind of have to decide where you're comfortable and work from there. All right, so example 2. We have the equation 2y minus 5 equals x minus 11. So when I look at the equation 2y minus 5 equals x minus 11, this really isn't in any special format. So at this point, I'm pretty much going to solve for y, and I'm going to put this in slope-intercept form. So hit pause, take a moment, and solve this equation for y. All right, welcome back. To solve this equation for y, you should have moved the 5 to the opposite side by adding 5. So we get x minus 6 because I need to solve for y, I'm going to divide every single term by 2. I encourage you not to draw one big line and put 1, 2 underneath them. Again, it opens the door for mistakes. Some of you are fine doing it that way, but some of you open the door for misconceptions. So if I look at this function, I have a y-intercept right here of -3. I have a slope of 1/2. So I'm going to go up 1 over 2, up 1 over 2, and now I'm able to draw my line. All right. 3, y plus 7 equals 9. So I am looking at this equation, and I notice something's missing. When I look at this equation, the first thing I notice is, there is no x. So I am going to take the equation y plus 7 equals 9, and I'm going to get that y by itself by moving the 7 over to the other side. And now I have the equation y equals 2. And as we have discussed in class, this is going to cross the y-axis at 2. So if we cross the y-axis at 2, it is going to be a horizontal line. So horizontal line. And just a little added bonus, if you have a horizontal line, recall that the slope is 0 because we run, but we don't rise. So when we think of rise over run, we can run, but we do not go up and down. So my 0 is in my numerator. All right, so it says graph the line through point P and perpendicular to the given line. So again, like we talked about in chapter 1, I encourage you to go through the question and think about important geometry words. So I look at the word perpendicular. I need a line perpendicular. So I have to ask myself, well, what do I know? I know about slopes, okay? So if I can find the slope of my line, I could find the slope of the perpendicular line. So I'm going to come over here to my picture, and I'm going to pick a point, and I'm literally going to count my slope. Rise over run. So rise, 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 and then I'm going to run. So I went up 3, and I went to the left 1. So I have a slope of -3 over 1. If I want the slope of the perpendicular line, please use good notation. So like this little perpendicular symbol right here is important. I will be looking for that on quizzes and tests. So if I find the slope of the perpendicular line, I'm going to take the opposite reciprocal. So my original problem had a negative, so this is going to be positive, and then take the reciprocal of 3 over 1, and I get 1 over 3. So now my perpendicular line is going to go through point P and have a slope of 1/3. Now, I look at my picture, and if I go over here to point P right here, I can't really go up 1 and over 3 to the right because I don't have enough room. You can also think of this as down 1 to the left 3 because a negative divided by a negative will also give you a positive. So let's try that. If I'm at point P, I can go down 1 and I can go to the left 3, and I can go down 1 and to the left 3. And using that information, I can come in and I can draw a line perpendicular to the original. So remember, as you look at all these problems, ask yourself, what do I know and where do I need to go? So example 5, graph the line with the slope of -2/3, which goes through the point -2, 1. So you either need 2 points to graph a line or you need a point and a slope. So 1, I'm going to graph the point. And then 2, I'm going to count the slope. So if I go to my graph and I plot the point -2, +1, going to go left 2 and up 1. And then my slope is -2/3. So remember that -2/3 could be -2 over 3, or it could be 2 over -3, either way. So down 2 to the right 3, or I could go up 2 and to the left 3. And at that point, you have enough information to draw your line. All right, moving on. Looking at the equation y equals 1/4 x plus 3 minus 2. I see that as being an HK form, or it's just point slope form with the -2 moved to the other side. So some of us look at this and we see y equals a times x minus h plus k. So I see that I have an a, or a vertical stretch, of 1/4, and I use the point -3, -2 to graph that. Some of you will go for option 2, and you will move this 2 back over here so it matches point slope form. It doesn't really matter to me how you do this. This is really y minus a -2 equals 1/4 x minus a -3. So if we think about what point we plugged in here to make this happen, we plugged in an x value right here of -3, and we plugged in a y value right here of -2. And I still have a slope equal to 1/4. So either way you got the point and the slope, it doesn't really make a big difference. It's just a matter of perspective and how you see the problem. Some of you will go ahead and solve it for y, and you'll distribute and do slope-intercept form. That is also a third alternative. So if I plot the point -3, -2, I have a point right here. I'm going to go up 1 and to the right 4, or you could go down 1 and to the left 4, and at this point you have a beautiful, beautiful line. All right, that's all the notes for today. We will tackle homework 3-7 in class tomorrow. If you have questions, please make sure you have them highlighted or written down so you can ask them when we come to class, and hope you have a great evening, and I will see you tomorrow.